Section 4.3, Logarithmic Functions, Part 3. We are still working with the properties. No matter the base, if we're taking log any base of 1, we always get 0. That would be something like log base 4 of 1. It doesn't matter the base. If we're logarithming 1, we're going to get a 0. Logarithms and exponentials are inverses, so when the bases match, they cancel each other out. They inverse one another. We would be left with 1. When their bases match, they cancel each other out. We'd be left with x. When their bases match, we cancel them out. Their inverse functions, we're left with x. Okay, so let's look at how to apply our properties to the examples that we see here. Okay, so this is log base 3. This is exponential base 3. Because they're the same base, they cancel each other out. And so we're just left with 7. Okay, so here, if we look at log base 4, we want to know what we can raise 4 to, what power, in order to get 64. That would be 4 cubed. So all we did was we took 64 and we rewrote it as 4 cubed. Now because the base and the exponential base are the same, this becomes 3. Okay, in a similar fashion, we're going to take 125 and see if we could write it to 5 to some power. If we look at 5 to the third, 5 to the third is 125. So we're looking at log base 5, 5 to the third. These are the same, they cancel out, and so we're left with 3. Okay, so continuing on with examples, log base 2. Can we raise 2 to a certain power to get 32? And that's going to be 2 to the 5th. 2 to the 5th is 32. Since these cancel, they're the same base, they're inverse functions, they undo one another, we would be left with 5. Log base 8 of 8, we're just getting 17. What rule we're using is this one here. If the bases are the same, we cancel them out, leaving us with whatever's in the exponent. Okay, how about this one? 6 and 1 aren't the same base, so we're not just canceling them out. Okay, so when we look at this problem, here's the rule that we're using. No matter the base, whatever base you have, if you're logarithming 1, this is always going to be a 0. Now, if we want to look at why that happens, and maybe a way that we can remember, well, let's just go ahead and write 1 as 6 to the 0 power. Then the rules that we've been applying, the log 6, exponential 6, cancel out, and there's how we're getting a 0. Okay, what is the base of ln? Base of ln is e. E and e cancel out. Square root of 3. E and e cancel out. 1 over pi. 10. Remember, if the number is missing, it's understood to be base 10. 10 and 10 cancel out, and so we're left with 13. The properties help us to easily simplify our expressions. Okay, so use a definition to find x. We're solving for x. Okay, so let's think about what these problems do. If I want to solve for x, I want to get rid of log base 3. What undoes a logarithm? An exponential. So we're going to exponentiate base 3 on both sides. Exponentiate of the same base, so that these cancel. We're left with x equals 3 to the negative 2, which is 1 over 3 squared, which is 1/9. Okay, logarithm, what undoes a logarithm? An exponential. An exponential of the same base. So we're exponentiating base 5. This becomes the exponent of 5. X becomes the exponent of 5. We do that so we can use our rules to cancel those out. So we get 125 is equal to 5 to the x power. What can we raise 5 to in order to get 125? And that's going to be 3. Okay, now on this one, let's go ahead and solve this one other different way, just to get a variety. We're going to come out with the same exact answer, just in a different way. Some of the practice that we have been doing is, how can I write 125 as 5 to what power? 125 is equal to 5 cubed. We didn't do anything. All we did was rewrite 125 as 5 to the third. And when we did that, we saw that the log base 5 exponential base 5 cancel, and we're left with x equals 3. Okay, so this doesn't work all the time. Here we're going to just kind of look at this for maybe the rest of the problems. Let's see what happens. Okay, log base 4, we're going to exponentiate base 4. Those cancel out, and so we're looking at 2 is equal to 4 to what power? Okay, so let's go ahead, since we ran out of room, I'm going to rewrite this over here. Now, what if we wrote, instead of 4, 2 squared? Do you agree that 2 squared is 4? It is. So we can actually write it this way. Since these are the same base, I can equate the exponents. Okay, log base 4, we exponentiate base 4. Those cancel out. 4 squared is 16. We can use the properties to solve that one pretty easily. Okay, how do I get rid of log x? I exponentiate base x. So we have 1,000 is equal to x cubed. What can I cube in order to get 1,000? 10 cubed is what I can cube to get 1,000. So x is 3. Okay, exponentiate base x. Those cancel out. We want to think about what can I square and get in order to get 25. 5 is what we can square to get 25. Okay, that's the end of this part of section 4.3.